Need to expose custom tools to Claude Desktop that actually work? You'll see how to create a complete FastMCP server in just 10 lines, from defining an AI callable dice rolling tool to installing it in Claude Desktop with a single CLI command. The pattern handles dependencies, environment isolation, and even remote server proxies, all while keeping the core logic this simple.
Import random. From FastMCP, import FastMCP. MCP equals FastMCP. Name equals dice roller. At MCP, tool. Def roll dice, end dice. Int list int. Roll end dice, 6-sided dice and return the results. Return random. Randint 16 for in range end dice. If name equals main. MCP, run.
This demonstrates the tool registration pattern for AI integrated services. The decorator-based approach transforms ordinary Python functions into callable tools that AI systems can discover and invoke, while maintaining clean separation between business logic and interface contracts. What makes this distinctive is how it leverages Python's native type system to auto-generate API schemas without requiring manual documentation or validation code. The pattern works by treating decorated functions as self-describing capabilities. The framework introspects type hints and docstrings at runtime to create a machine-readable interface, while your implementation remains pure Python with no framework-specific dependencies. This declarative style shifts the complexity from implementation to registration, letting you focus on core logic while the framework handles transport, serialization, and discovery. This approach solves the integration complexity problem for AI tooling. Instead of building custom APIs or adapting to rigid SDKs, you expose capabilities through natural Python functions that work across different AI platforms. The trade-off is framework coupling at the decorator level, but the benefit is dramatically reduced boilerplate and automatic compatibility with evolving AI tool standards. It's particularly valuable when you need to expose backend logic to multiple AI clients with minimal adaptation. Let's break it down line by line.
Import random.
This imports Python's built-in random module, which provides pseudo-random number generation. It's required here to simulate dice rolls with random, randint, the core functionality of this tool.
From FastMCP, import FastMCP.
This imports FastMCP, the core class for building AI callable tools. It provides the decorator and runtime that expose Python functions as structured tools for AI models, handling serialization, validation, and execution.
MCP equals FastMCP. Name equals dice roller.
This instantiates the FastMCP server with the name Dice Roller. The name identifies this toolset in the AI's available functions, and the instance becomes the central registry for all at MCP tool decorated functions.
At MCP, tool. Def roll dice, end dice. Int list int. Roll end dice, 6-sided dice and return the results.
This decorator exposes roll dice as an AI callable tool through FastMCP. The type hints and docstring automatically generate the tool's schema, including parameter validation and return type enforcement. FastMCP uses this pattern to bridge Python functions with AI model capabilities.
Return random. Randint 16 for in range end dice.
This is a list comprehension that generates end dice random integers between 1 and 6, simulating dice rolls. The underscore discards the loop variable since we only care about the count, not the iteration value. This pattern efficiently creates the result list in a single readable line, avoiding explicit loops.
If name equals main.
This is Python's standard entry point guard. It ensures MCP, run, only executes when the script runs directly, not when imported as a module. Without it, importing this file would accidentally start the FastMCP server.
MCP, run.
This launches the FastMCP server, exposing all decorated tools to AI models. Without this call, the tools exist but remain inaccessible to external systems. Standard entry point pattern for FastMCP applications. FastMCP tool decorator pattern. That MCP tool decorator transforms ordinary Python functions into AI callable operations, automatically generating schemas and handling transport protocols without explicit configuration. Tool names in the decorator must exactly match the function names, as FastMCP uses this for both registration and discovery. This single decorator bridges the gap between local Python execution and remote AI model integration.
The decorator that names the tool becomes nameless to the client.